In this video, I introduce a bidirectional recurrent neural network. A recurrent neural network is a sequence-to-sequence model that maps input sequence to output sequence. For example, to predict the current output, the model first uses a past hidden state and current input state to update the current hidden state. And then I use the current hidden state as the input to predict the current output. From here, we can see the current prediction only uses the previous input information and the current input information. However, in some cases, we need both the previous input information and the future information together to correctly predict the current output. To do so, an easy idea is to add a separate hidden state channel. That means we have two state channels. One is forward, one is backward. They share a same input sequence and they merge together to predict the sequence, output sequence. Let's see the update procedure for the bidirectional recurrent neural network. For example, we have here the forward hidden state channel is here. This is the initial hidden state. This is first, this second, and the third, and so on. We can have more hidden states. And the backward hidden state channel, here is the initial hidden state. Is a first backward hidden state. Is second, is third, and so on. We may have more. As we mentioned, the forward channel and the backward channel, they share the same input sequence and they have the same output sequence. First, we see how can we update the forward hidden state here. This is the forward hidden state nonlinear activation function. We just use the previous hidden state and the current input plus the bias together as the input to the nonlinear activation function. And then we generate this forward hidden state. I follow the same idea we use from the different direction. Here is the input hidden state for the backward hidden state channel. And then now we use this previous hidden state as a part of input, and we use this input as a part of input to the nonlinear activation function. That means we put the previous hidden state, current input, and the bias together as the input to the nonlinear activation function. And then to update the current backward hidden state. So once we have got the hidden state from the forward direction and the back direction, and then we put them together as the input to this nonlinear activation function, plus this bias together as the input to this nonlinear activation function to predict the current output. So in this way, the current prediction uses the information from the previous input and from the future input together to predict the current output. For more details, please check with this reference. Thank you.